So, hello everyone, welcome back to the class. Today we are again continuing with chemical bonding. Two topics we have done out of the three. We have already done electrovalent and covalent bond. Today we are starting with coordinate bond. So let's start with coordinate bond. Okay. So what is this bond? Now, this bond is formed between two atoms by sharing a pair of electrons. Okay, both of which are contributed by only one of the atoms. This is a very important point, that here sharing is occurring but only one is contributing to the bond, okay, but shared by both atoms, and this is called coordinate bond. The atom which provides the electron for the formation of a coordinate bond is known as the donor, and the one who receives or accepts the electron is known as the acceptor. Okay. So sorry.
No, that is ionic bond.
So coordinate bond has properties of both covalent and ionic bonds. Okay, means both. Covalent does what? Covalent shares, and ionic transfers the electrons. Thus it is known as co-ionic bond. Means co stands for covalent and ionic stands for ionic bond. Co-ionic bond. Okay, a pair of electrons which is not shared with any other atom is known as the lone pair. This everybody must have heard. Okay, the coordinate bond is shown by an arrow with its head pointing from the donor to the acceptor atom, like this. Here is the donor and here is the acceptor, like this. An arrow is shown. Okay, so let's now see some examples of covalent bond, coordinate bond. I'm sorry. So we have already heard much about it. I've already told you all. So let's start. So first of all, what happens is, in this a special thing happens. Only one atom shares.
Or in which college do you study?
The next point. The next point is that they show the property of both ionic and covalent bond. Okay, so that is why they are known as what? Co-ionic bond. Is it clear? And how are they represented? How are they represented? They are represented by an arrow. Okay, this is shown by an arrow. Okay, now here's the donor, here's the acceptor, and in between is the arrow. Donor is giving to the acceptor. Okay, this arrow we are talking about. Is it clear? Let's move on to some of the examples. Okay, but before the examples, let's discuss about the conditions for the formation of coordinate bond. Okay, what are the conditions for the formation of it? So in, like in yesterday's class also, we studied many conditions, right? Ionization potential should be high, electron affinity should be low in ionic one, right? So, or I'm not saying the correct thing, but yes, we have studied yesterday. Okay, so today also we have some conditions in this too. So conditions for formation. Okay, so let's say some conditions for formation. So one of the two atoms must have at least one lone pair of electrons. Okay, first, one of the two atoms should have, okay, should have one lone pair of electrons. Okay, lone pair I've already told you. The pair which is not connected, it's lonely. So that's why lone pair. Okay, like this it is. So lone pair of electrons. Okay, one should have lone pair of electrons. Okay, next, while another atom should be deficit, means should have the deficiency of at least one lone pair of electrons. Okay, so it should be deficit in the lone pair. Okay, so let's write. So and The other, let's write it nicely. So while, okay, while the other should be deficit, okay, deficient or deficit of at least one lone pair of electrons. I'll tell you some examples and you'll understand by that. Okay, so let's discuss some example. The first example is ammonia. Okay, so in this we have to cover two topics, actually not, no, we have to cover three topics. The formation of ammonium ion, that is NH4. Okay, ammonium and ammonia are two different things. Ammonia is NH3 and ammonium is NH4. Okay, so we have to deal with formation of ammonium, the formation of hydronium bond, that is H3O plus, and then the formation of hydroxyl ion. Okay, so just be focused, because in the next chapter we'll be dealing with this hydronium ion again. Okay, so you have to be known to it. So first of all we will study about formation of ammonium. Okay, ammonium ion. Ion is something which is having a power. Okay, so let's write it like it's having a power NH4 and it's having a positive power. Okay, so let's now discuss how is it formed. So see, ammonium ion is formed from ammonia molecule and one hydrogen ion is added to it. Okay, like I have NH3 plus I did one hydrogen, and what I got NH4. Okay, this is not the correct equation, but it is something like that only. Okay, so how to just represent it in a form, in the form of a dot structure, electron dot structure. So how to write it? Write it like this: write n in between, and we are having how many h's? We are having how many h's? We are having three h's first of all. So what we have to do is NH3 plus H we have to do, and then we'll get NH4. So just now make a figure of this. So NH3 is having how many h's? It's having 3H. So one H here, one H here, and one H here. And let's make the electrons. How many electrons is it having? Nitrogen has 5 valence electrons. Yesterday we have already discussed this thing, right? So it is having 5. So one will be shared to hydrogen, one will be shared to this hydrogen, one will be shared to this hydrogen. 2 is left, so 2 will be left, and hydrogen will share this. Okay, now see here. This is what? This is actually a lone pair. Okay, this is only called a lone pair. So tell me, is it fulfilling the condition? So see, this is the lone pair which I was talking about. Let's move ahead. Let's now look at how one hydrogen atom will be added to it. So let's make the structure again: N and 3 H's like this. One cross means it's having one electron in its outermost shell. This is for hydrogen. And nitrogen is having 3 electrons, which is shared to hydrogen, and 2 are a lone pair. Okay, now what will happen? See, let's make it more systematically. Okay, let's make it more systematically. We'll make it like this so that it is easily understood how this sharing is happening. So 1, 2 will be here, one will be shared here, one will be shared, one will be shared here, and here is 3 hydrogens. This is again ammonia only, ammonia. Okay, NH3. Now what will be added to it? Hydrogen will be added to it. Okay, hydrogen, H plus ion. Okay, hydrogen ion. This is the donor, and this is the acceptor. Okay, this is ammonia, and this is hydrogen atom. Okay, no, not hydrogen atom, it's an ion. Okay, because it's having a positive charge, so ion. Okay, these things are to be kept in mind. Next, what will we get? We will get this n. 3 bonds were there with the hydrogen, yes or 1, 2, 3 hydrogen were there actually before only. but now this new hydrogen will be added to it. Okay, so one more new hydrogen added to it, and we'll make an arrow which says that it's sharing. Okay, and this is what we call as coordinate bond. We are having a plus power on it. Okay, is it clear, everyone? So this is only called the coordinate bond. Okay, let's move on to the next and the second one, which is very, very important. I will, I'll just tell you about hydroxyl first, and then I'll tell you about hydronium. Okay, so let's first talk about hydroxyl, though it's in the third place in the syllabus, but let's discuss it first. So formation of hydroxyl. How do we represent hydroxyl ion? Hydroxyl means the one which is with the bases, that is OH minus, isn't it? OH minus. How to represent? So we can see here that we are having, what do we have to do in this? First of all, and the hydroxyl ion or the hydroxide is formed when hydrogen is removed from water. Okay, we are having a water molecule and we deduct hydrogen from it, and then we'll get what? OH left. Why? Because what is the real formula of water? The real formula of water is H2O. Yes. How many H's are there? Two H's are there. One H has got subtracted, and then we have got only one H left and one oxygen left. Is it clear or not? Clear now? Yeah. So like this only we get this hydroxyl or hydroxide ion. Okay. So let's discuss how do we get it. So first of all, we'll make an atom of water, oxygen and hydrogen. In the last class we have already done its structure, so if you have not watched it, go to the YouTube videos, go to my channel, and then you can just see the videos how is it bonded. So I'll not tell you. If you don't know, you can just watch the videos. Okay, so how is it done? See, oxygen is having 6 electrons in its outermost shell: 1, 2, 3, 4, and 5, 6. Okay, and hydrogen is having only one. Hydrogen shares. Okay, but water attracts it. So now see, this is a water molecule. Water molecule. Okay, now draw an arrow. It will be changed to what? We want an hydrogen to be separated here. -1 hydrogen. So what we'll get? Hydrogen will be taken out. One H plus ion will be taken out from it. Okay. So this is an hydrogen ion. Okay. And we are left with what? We are left with OH minus. That is O and H. Okay, so O is having how many electrons? It's having 6 electrons. So 1, 2, 3, 4, 5, and 6. Okay, and hydrogen is having how many? Hydrogen is having 1 electron, its outermost shell. So now see what is happening. This bond which was there is now no more. Okay, it will be drawn in the figure, but now this hydrogen which has shared its electron here is detached from it, and we are having how many lone pairs? Who will tell me? We are having 1 and 2. We are having 2 lone pairs. This question is asked. So we are having how many lone pairs? We are having 2 lone pairs. Okay, we are having 2 lone pairs. So after the removal of hydrogen ion from water, the shared pair of electrons remains with oxygen. Can you see the shared pair of electron is always with oxygen only, but oxygen, why is it with oxygen? Because oxygen is more electronegative. Yesterday I've told you what is electronegativity. Yes, the property of attracting something towards itself, like we have hydrogen, oxygen, and hydrogen. That is the structure of water. Okay, so 1, 2, 3, 4, 5, and 6. So now see, what is happening in sharing of electrons? What happens? This remains here, this remains here, and we draw a bond like this, isn't it? We draw a bond like this. But here is the same thing happening. No, what is happening? Actually, oxygen is very clever. Oxygen has taken this electron towards itself. Can you see it has taken the electron towards itself? Can you see that? Yes, is it clear? So we'll say that hydrogen oxygen is more electronegative. Okay, it's electronegative. So what will happen if we'll remove this hydrogen also? Then also his electron will be with oxygen only. And what will be the bond? What will be the power on it? Tell me, what will be the power on it? It will be minus. Okay, it will be minus. So power will be minus. And these are the two lone pairs. Done. Now let's move to the last example that we have of formation of, give me a minute guys, I'm so sorry for this. My pen doesn't work sometimes. So formation of hydronium H3O plus. Okay, this we'll study in the next chapter. We'll begin the chapter today itself. Okay, hydronium. So how to get this hydronium? We know that when one more oxygen is, when more hydrogen is added to water, H2O. Now tell me, two hydrogens were there. Now one more has come. How many will we get? Isn't it? Is it understood? How have we got this hydronium? Yes. So in the same way, we'll make the whole thing. So first of all, make the authentic atom. The authentic, the real, the original atom is actually H2O. So make the structure of H2. I've made it hundreds times. So now I'll not explain it. 1, 2, 3, 4, 5, 6. Okay. And how many? 1 and 2. Okay. What will happen to them? We'll add one hydrogen atom to it, a hydrogen ion to it. Okay, don't mess up with ion and atom. I generally mess up with them. It's very good for my exam point of view. Okay, so here is hydrogen and hydrogen. So this is what? This is a water molecule, and this is what? This is a hydrogen ion. See, again I've messed up with it. So ion. Okay, let's now share it. So we are sharing it. So what will happen when they will both combine with each other? We'll get H3O. So means three hydrogens, hydrogens will be there, right? So O, H were before only. So now see what was there. This was already there. 1, 2, 3, 4 and 5, 6. Okay, so what has now happened? This lone pair has shared with this, right or not? So we'll erase the whole thing and we'll make what? We'll make an arrow to indicate that here coordinate bond is being formed and this is a lone pair which is left. So label it. If it comes in examination, key write the formula. Okay, so you have to just label it positively. Okay, so now see what is this happening. This is the coordinate bond. Okay, this is the coordinate bond. Done. So and this is what? This whole ion is a hydronium ion and it's having a positive charge. Okay, so it's having a positive charge. Is it clear? So that was all for this chapter. We have covered the whole syllabus which was associated with the chapter chemical bonding. Each and every point which is mentioned in the syllabus is completed. Nothing will be asked beyond this. Okay, And thank you for watching. Please like, share, and subscribe to my channel.